Okay, let's start. Fine. So yesterday, I think we looked at most of the terminal operations on stream. Yeah. What were the terminal operations on a stream? Quick look. And so we were looking at stream of T. Given a stream of T, yes. Which are the terminal operations? What were the terminal operations? Fine. You have the method to return long. Fine. That's count. Okay. What else? Yeah. Methods which would return Boolean over the entire stream elements. So one of them was all match. Fine. Takes a predicate, some predicate of T to test. So predicate of T is some test. Okay. And this would return Boolean value. Okay. Fine. Whether this test is passed by all the elements of the stream, satisfy the test or not. Fine. Same way, we have another method called none match. None of the elements satisfy the test. Fine. We even have another method called any match. Fine. That would also take predicate. So at least one of them satisfies the test. Yeah. What else? Fine. Getting some element. Okay. So yes, there are two different methods to return, but these methods, since the stream might be empty, fine, to make a provision for empty stream, the return type here is optional. Fine, it returns optional of T. Method name is find any. Fine, or you could again get optional of T by using the method called find first. Okay, find first would be used on a sequential kind of a stream, ordered stream. Find any on a unordered stream. Okay, fine. What else? We can also do something like processing, some processing over all the elements of the stream. That can be done by the method would return void. Method was for each, and parameter would be consumer of the type T. This is the action you would like to take. Specify an action. Right? Same thing. Fine. This is for each would work on anything, but we have the for each ordered. And parameter is still the consumer, the action to be taken on all the elements of the stream which come out of the stream. Right? Plus, there are two more methods to convert into array form. So we had this method called to return object array. One method would return the object array. Two array method on a stream can return an object array. And other method was having a type parameter A. Okay, fine. The method would return array of A. Fine. Name of the method was toArray, but it would take as parameter a int function. A int function which could return array of A. Fine. That's our int function. Yeah. Fine. So in the stream, these are the initial terminal operations. Over and above these, we also have some advanced terminal operations. Okay, and which were those? And which were those advanced terminal operations? Yeah, reduce. Fine, we had the method reduce, which would return t, and name of the method is reduce, where the parameter would be, first parameter would be of type t for the identity, and second parameter would be a binary operator. Fine, of t, fine, which we can call as a accumulator. And the accumulator binary operator. Fine. Okay. There were two other forms of reduce. In this case, how does the reduce work? How does the reduce work? It would take as parameter. The first parameter is the initial result you start with. Okay. Fine. And then you get the elements from the stream one by one. With each one of them, apply the earlier result. Fine. Your initial starting result is the identity value. Apply the result using the binary operator. Fine. Get a result using the binary operator. Fine. In the binary operator, we are applying previous result and the element from the string. The new value will be generated, that is taken as the new result, with which we will again apply the binary operator with the next element from the string. Just keep on doing this. Fine. And you get your result. Fine. So here the result is of type T. Fine. A variant to this was, yeah, another variant was, oh, the other one would return optional. Second. And it could return optional of T. Fine. The same reduce method, but here we only pass single parameter, which is the binary operator. So you might just have a binary operator of T, which is used as the accumulator. And so if you have only the binary operator, the first element has to be used as the initial result. And it's similar to the earlier one, except for that you don't have a starting value, right? So in this case, if the stream was empty, fine, it should be, we don't have a result, and therefore the return type here is optional of T. Okay. Fine. Another reduce method would return, it has its own type parameter u, let's say, the return type will be u. Okay. It's similar to the, oh, yeah, it's similar to the earlier one, but with slight one more additional thing was used there. We have the method called reduce with parameters being u as the initial identity. The result type is not the same as the stream type. Fine. So you have your u type as your identity, result type is u. Okay. Second parameter would be a by function. Sorry. We'll have the by function. By function of u is my result type, first parameter, second parameter will be element from the stream, and the result should be the element of type u, the new result. Fine. So such a by function must be specified. This is what we call as the accumulator. And one more element which will be of type binary operator of u. This would be used as, this is considered as a combiner. and we call this as a combiner. Okay, yeah. How does this work? Yeah, we can say identity and a by function. The use is similar to the first kind of the reduce method, only difference being the result is not the same type as the type of the string. You can have a different type of result also here. Fine, U can be different from T. So two different, fine. U here is your result type. Okay, fine. But one thing, since you can have a parallel stream, it would mean that your stream can be divided into smaller partitions, each partition being processed independently, separately. So each processing party, fine, each one which is processing a part of the partition, part of your stream, is going to it's going to work on a part of the stream, is going to use the same identity value, initial value will be the same, will use the same binary by function, fine, and they will independently have their own smaller results on the parts of the stream would be available. And then what we need after the parallel processing of all of them is over is each part, fine, whatever result has been created, that needs to be combined together to form the final result. Okay, and for that we pass a combiner, which is there as a binary operator of U, the result type. It's the results which have to be combined, and smaller results to be combined to create a final result out of it. Fine? Clear? This is what we had seen yesterday. Okay, fine. So now let's have a look at the next thing. Fine. So this is clear part, right? This part? Okay. Fine. The next thing here is about using collector. Collector of a collector has three type parameters. Collector of T, normally whatever is the type of the stream, the element type, A, the accumulation type, accumulator type, and R is my return type. Fine. Collector of TAR. Okay, we have got collector of TAR. Oh, I think I'm jumping in. Let me come to collector later. Let me first put the two collect methods, two forms of the collect methods. I'll put the two forms of the collect method. Fine. The two forms of collect method are like this. Fine, in the stream, the terminal operations. Fine, so the last terminal operation which we are looking at is the method called collect. So the first one says it would return R, yeah, it has type parameter of R, okay. Return type is the result is my type R, fine. Name of the method is collect. But what's the parameter to this? First parameter is, oh sorry, there are two type parameters, A and R. Or rather, it's not R. R is not separate type. Yeah, sorry. A comma R. Returns R. नहीं ठीक है एक ही था. There was only one type parameter. Sorry. I've called it R. Let's call this as R as my result type. Okay. So the collector requires first is a supplier of type R. Okay. Supplier of type R. Right. This we call as a supplier. Second parameter is a by consumer. by consumer of, it will consume R comma T by consumer. Fine, it's a by consumer. This we call as the accumulator. And third parameter was, yeah, what's the third parameter? A by consumer again, right? It's a binary. Okay, third parameter is a binary operator. Not binary operator, sorry. It's a by consumer. By consumer of a, R comma R, sorry. And this is this is what we call as a combiner. First collect method was like this. Yeah, we do have another collect method. So this is one collect method. Okay, and the other collect method was like this. The other collect method, A है, हाँ उधर कल जो लिखा होगा उसमें A होगा. It might be called as A then yesterday. Did we write this method yesterday? Collect method? अच्छा, we didn't. Okay. हाँ. Is the result. It's my result type. Yeah. Fine. The result will be of this type. This is in the stream of T. There's no R. It's a stream of T. We want one more type parameter for this method itself. That is R. R is my result type. Right? So this R is for the result type. So method's return type is the R. So what it needs a supplier of R. It needs a by consumer with type parameters as by consumer of R and T. Okay. And third one is a combiner which is a by consumer of R and R. Fine. Yesterday we had seen about reduce. Okay. This is going to be different. Let me list the other collect method. Fine. And then we'll come back to looking at how the collector works. Okay. Here, no, we are not having collector at this moment. The method name is collect. Okay. Let me try to show. Let's first look at this method, and then we'll go to the next method of collect. There are two collect methods. This is one of them. Okay. How does this collector work? How does this collect method work? Okay. When someone calls the collect method, he is supposed to give a supplier of R. Right? So we have some supplier of R on which you will call the get method. So whatever is the supplier, you call the get method, you will get one object which will be of type result. Fine, that's my result type. Okay, fine. Now how it differs from the reduce method? It's almost fine, things are quite similar. What's the second parameter? Accumulator. Now you take the first element from the string. Okay, so this is my result type, let me call as R, and I have some element T1 from the string. Okay, what we'll be doing? What's the accumulator saying? It's a by consumer of R comma T. Fine. First object in that method. So you have a function which will take, by consumer means a function which takes first parameter as the first object, second parameter as an element from the stream, does not return a value. Okay, so what is going to happen? Yes, what is expected here is this object R, fine, is going to be updated. This object is going to be updated by using T1. You have both of these objects. First parameter is this, second parameter is going to be this object. You have a function which would, because it does not return a value, it is supposed, it is expected that this object effect on R would be taking place. So R is affected here. R undergoes a change. Okay, R will have some change in the consumer. The consumer here is going to take first parameter as R, second parameter as first element from the stream. Some update on R will take place on the object given by the supplier. First, you get an object from the supplier. When it has been updated with the first element, fine. The important difference now is this. Fine. Now, the next thing what will be done? So the effect of this is pushed into this. What will be done now? Takes the next element, fine, takes a second element from the stream and uses the accumulator again. When it is using the accumulator again, it has only that same element which was given initially from the supplier, that same object is reused each time. The same object is reused. So this object remains same. You have object T2 whose effect will be merged into this. Apply the by consumer. First parameter is that one object only. There's not derivation of a new object. When it was the binary operator, a new object would be created each time in case of the reduce method. In case of collector, no new object. The object given by the supplier is used all the time. That object is going to be updated with the element coming from the stream. I want to apply this by consumer on this object. Fine. So first parameter here, it says by consumer of R. R is your object given by the supplier. And on that object just keeps on applying the element from the stream using this. Clear? So second element, okay, or third element, the effect of third also goes into that same object. One object only from the supplier is taken. Fine. Keep on updating it with the element from the stream. Clear? Which means here that our supplier, what is supplier? It's giving the object of type R. R is some mutable type. It's not immutable. It's not something which will not change. Yeah? It is the one which is going to be updated. It is a mutable type. Fine. Whereas in case of reduce method, what was it? It was a immutable type. Fine. We can work with even with immutable items because we are not going to use the same object. We will use the operator, derive a new object, and the new object would be taken in the next step. Here, you have first step giving us one object, and the same object is reused all the time with the different elements coming from the stream. Clear? Accumulation is done in this single object. This object is mutable. Clear? The result object is mutable. It gets mutation and it gets updated. Now again here also, yes, we understand the meaning of combiner. Why combiner? So that we can combine two elements. Fine, see the effect of that, and that's what is being done. We will have one part of the stream getting a object from the supplier, result object from the supplier, and having its own set of elements updated in the result element. Same way, there will be a number of such R objects which have been created, fine, to take care of different part of the stream. It has been for parallel processing purposes, it has been done separately. You will have multiple objects of type R, and then you need to merge them. And that's where we have the combiner which is a bi-consumer of R and R. Find the first element, another result which is ready, applied on this one. Fine. Now you are not applying in the using combiner, you are not applying elements from the stream, but you are applying the result of some part of the operation. Here, different parts were there. Fine, for parallel processing. So each parallelly processed, separately processed result is going to be merged into the result number 1 by using the combiner. Fine, both are of type result. Fine, it is expected that it should be updating the first parameter. Clear about this collect method? Okay, fine. Now the other collect method, this is one collect method. The other collect method takes as parameter collector of T, comma, you can give me any accumulation type, comma, R. Fine. Fine. It's a collector C, which is a parameter, and what it returns? It returns the value R. So R is my type parameter. If you got a collector of T, second type doesn't matter to me, accumulator type, R is my result type. It works on this type of elements of type T, on a stream of type T. Okay, but it is going to produce the result of type R. Fine. So that's a collector. Collect method using collector. What is a collector now? Oh, someone has to build a collector. Yeah, the method signature, the type parameters for collector. Yeah, what's a collector? I'll just put it here. The collector, now from the collector interface, look at the collector interface. Collector is an interface. Collector of T, comma, A, comma, R. That's the accumulator. Not accumulator, sorry, this is a collector. Yeah. Fine, we have this interface called collector of TAR. Collector is interface. And collector is interface, collectors S, that is a class. Yeah, let's see what is a collector now. And we understand this collect method with 3 parameters. What is the idea here in a collector? Supplier is there, which creates one object for me. Fine. And then what we do? Merge the elements coming from the stream into this object available from the supplier. Object given only once. And the same object is updated each time. Fine. We need a supplier. Fine. Collect method, yes, we go, so it needs a supplier. We have another role, which is the role of accumulator, which is going to be the bi-consumer, second parameter. Okay. Third parameter is slightly different from what is mentioned here. The third parameter is a binary operator of A, comma A. Fine. The third value. And fourth, the 4 things which a collector is made up of. Collector is made up of 4 objects. Fine. We are saying, oh, I want to pass a collector. Instead of passing 3 parameters separately, you create one object of collector and use it. But what is there in the object of collector? In the object of collector, there are four objects. Okay, so what is a collector looking like? Okay, a collector looks like this. When I say collector of TAR, right? What is a collector? So if I look at this as an object of collector, within this object there are four more objects. The collector object has got four objects. And which are those four objects? The first object here is, we call it as a supplier object. Okay, the supplier is of type, it will be a supplier of A. Right? A collector of TAR, yes, there is a supplier of A. A is my accumulation type. I'll accumulate in the elements of type A. So my supplier will give me the initial object in which I can merge elements of type T. Okay, so what's the second object? The second object is the accumulator. The data type for this is nothing but it's a by consumer, which consumes A, comma, elements from the fine, A, comma, elements from the stream by consumer of A, comma, T. That's my accumulator. Second object. Okay. Now again, doing things in parallel, so small results are available. Now what we have is a third element, which we call as the combiner. Fine. The combiner, the type for the combiner is binary operator of A. It's a binary operator of A, the accumulator type. So small results, the results here, intermediate results I'll say, accumulated results are of type A. The final return value is of type R. But you can understand, like the earlier collect method, we have one object, what will be done? Different parts will be there, it's fine, it's broken into smaller parts. For each part, take the first element from the supplier using the get method. What you will be getting will be an object of type A. Fine. Then merge the elements from the stream by consumer, right? Small results will be of type A now. You have the A objects which were given by the supplier to different parts. Each of those A objects, fine, combine them. But here for combining, it's not a consumer, they have used binary operator. Fine, it results in the final object of type A. Fine, now you got this object of type A and you still further want to do some action on it, do some transformation on it and give the final result value. This is what we call as finisher. So you can have a finisher. The type for the finisher is nothing but the function of A to R. So result will be of type R. Fine. On the final object of A, the finisher is applied to convert from A to the result type R. So result type is different from accumulation type. Fine. So that's what a collector is. Collector is nothing but these four objects put together. So you first create a collector object using these four type of objects and then pass it in the collect method, then you will get the result. You need to pass such an object in the collect method to get the result. Okay, when this is fine. Fine, how it is working is clear. First use the sub, it uses, see you think that okay, for parallel processing you have divided into smaller part. For each part independently, what is going to be done? Use the supplier to get the initial object of type A. Clear? Use the get method on supplier, you will get the object of type A, accumulator type. Okay. Second, for your part of the of the stream, what are elements you are going to get? They will be of type T. You have a buy consumer, which will be given the first parameter as nothing but the object of type A, accumulator type, the one which you got with the help of get. Supplier has given one object, so that object is only one per part of the stream which is to be processed. Right? Your stream is broken into, let's say, 7 parts or 8 parts, let's say, right? To the 2 to the power of 3, fine. So it has been divided into 8 different parts. Now for each part, independent processing, so each one creates one object of A by using the get method. Gets some initial object. In that, it will keep on merging by using the buy consumer method. That first object which you got from the supplier is reused with, it is fine, it's going to apply the buy consumer A. A is my accumulation type which I get from supplier. On that object, merge the elements of stream T. Fine. So you have, because you had 8 different partitions, you would have 8 different objects of A, right? Because there are 8 different objects of A. First and second object, apply the binary operator to derive one more object of A. Binary operator of A means 2 inputs, 1 output, all of them of the type A. Fine. So I have to, this is combiner is used for combining the results which is derived independently, fine, by doing a parallel processing. Start combining them, fine, and ultimately you combine first and second, third and fourth, fifth and sixth, fine, the combination of first and second to be merged with the combination of third and fourth, fine. Same way, fifth and sixth and seven, eight, they will be combined. And then again, their top level again combined. Ultimately, you get a single value of type A. Fine, you will get a value of type A because it's a binary operator of A. One single value by combining all of them. Okay, and then have a function which converts from A to R. Apply a finisher on the result by using all the combiner of it. Fine. So that's a finisher is nothing but a function from A to R. So that's how it becomes a collector with 3 type parameter T. T is the type, the streams, the type of the objects it's going to process. A is the accumulator type and R is the result type. Fine. Okay. Fine. Now, how do we create a collector? Fine, collect method we need to pass this, right? But first we'll have to create collector. Oh, we see this collector requires 4 objects. So there's a convenience method in collector which you could use. Okay. I want a collector of TAR. Okay, and therefore what you need is, yes, uh, collector of TAR. We have the static method in the, sorry, Fine. We got static method in the collector interface. Collector interface has a static method to return collector of TAR. How? By using the method called of. What's the parameter? What are the parameters? First parameter will be of type supplier. Fine. So of requires supplier of A. That's your supplier. Second parameter of type yeah, it's a by consumer of what will it be? A comma R. A comma T. Sorry. A comma T. Yeah. Yeah. This we call as the accumulator. Third parameter binary operator of A. This we call as the combiner. And the last parameter is of type function, which converts from A to R. This is what we call as the finisher. Oops. Fine. Oh, there's one more parameter to it. There's still one more parameter. I have not put it. Okay. Let me put. Still one more parameter after finisher is the parameter of type collector dot characteristics. Collector dot characteristics. And it's dot dot dot. The characteristics. Characteristics. Collector dot character. The characteristics are passed here. Okay. And there are various characteristics of a collector. And it is sized collector. I know what type of thing it is. Okay. Okay, since it says dot dot dot, even if you don't pass, you may have 0 parameters for the last one. Fine. So just passing 4 parameters of method is sufficient. Fine. Okay. So creating collector, this is one way. Dot dot dot. Where args? You have seen that earlier. Printf recollect. Characteristics. Characteristics. It's a variable name. Does not matter much. Okay, fine. Okay, now, fine. Now, creating a collector object using the static method of would require that we develop at least those four types of objects. We need to have those functions created, then we can do it. Okay. Now, for lot many situations, we have ready-made collector creation available. We can easily create collector objects. We don't have to write these four types of things, okay, without writing them. Let's see some of them. We have this class called collectors. That's a class. Okay. Some simple examples of creating collector objects. Fine, for some scenarios. Fine. So if you want a collector which can do the counting job, okay, we have a collector called counting. See, what will be returned? It's a static method. So collectors has a static method to return a collector of, fine, the type of elements to be processed is T. Okay, so this is a static method and it has here, it's got the type parameters T comma, yeah, that's it, T. Okay, T comma, it does not matter what is my accumulator type, but what is matters is what will be the return type value. The return type, because it's a counting, the return type value is long. Name of the method is counting. No parameter. You can just say collectors.counting. It would create a collector object which can do the counting job.
स्टैटिक इंडिकेट करता है कि ये मेथड स्टैटिक है और वो
Method in the collectors class.
मेथड इन द कलेक्टर क्लास सो एंगुलर ब्रैकेट्स के अंदर टी से क्या बदल जा रहा है
This one. After static here,
यस सर
this is the generic method and uses one type parameter T. And generic method has a type parameter to be mentioned before the return type. Fine. What does this method return? It returns collector. So before collector, at this place, we got the type parameter name. There's only one type parameter. Counting. Static method in collectors class to give us a collector which takes whose elements type are T, but they return long. A is my accumulator type, it does not matter to me, so we put a question mark. Fine, we'll see how to use them. And we'll be seeing how to use them. Okay, fine, this is the first method. Another method, oh, I want to be able to find the averages. Find a collector which can find the averages. Find average on what? Average can be done for primitive values. Fine. Oh, if it is integers, I can do averages. Clear? Integer, long, or double. When there we can use Yeah,
Average.
average. Okay. So we have three different methods. Fine. You got a stream of some type T, and therefore here you might get a static method to return a collector which collects element of type T. Accumulation does not matter, but the return value will be a double. Right? Like the counting method, here we have the method called, there are three different methods. Their return type will be like this only. Name of the methods are different and the parameters are different. So this one takes as parameter, the name of the method is averaging int, and the parameter to the averaging int method okay, averaging int takes as parameter to int function of t. Sorry, averaging int is the method name. Parameter to this, yeah, is the to int function. Fine. Okay, let's see this. Okay, now the other two averaging methods are as it is, fine, they are similar. Okay, yes, we have the static method to return a collector of t question mark. Name of the method would be averaging long, parameter to long function of t. Oh, oops, sorry, one mistake we have done. Yeah, no, that's okay. Too long function of t. Right? That's your transformation function. And same way, method to return, name of the method would be averaging double with parameter as 2 double function of. And I'll show you how to use them now. And there's just a few sample methods available from collectors class. Let's just look at this method averaging long. Fine, let's just use averaging long for example here. Okay, we are interested in average of all balances. Fine, average across all the balances of my account.
So,
Yeah,
so collector angular bracket is a T question mark
yeah,
double.
yeah, yeah.
Averaging long as well.
Mm-hmm.
So what a
Yeah.
long
Either T, no. All of them double, all of them same T question mark double. They are all returning collection of T question mark double. Okay, fine. It's collector of T is my type of the elements to be handled by the collector, right? Question mark, the accumulator type doesn't matter, but the result type is double.
so averaging long
Huh. What is average? Floating point, that's your answer. What's the result? What's the type of the result? When we say counting, what's the type? It will return long. Result is going to be a long. for when we count. When we do average, the result is a double. That's the result type. The third type parameter is the result type. Fine. We are saying averaging int. So average over integer values. Average of integer values. But the average computation is going to result in a double. Clear? What do we have to pass as parameter? When I say averaging long, what do I pass parameter to this? A too long function. Fine. A too long function of t, which takes input as t and returns a long, and then averaging long. Averaging the long generated by conversion from your account to a balance. Average of all the balances. How do I get average of all balances? And you will be surprised to look at the amount of code needed to get the average of balances across all accounts in that bank. Oh, you have a bank object? Okay. So we got a bank object, right? Let's say. Right? Okay. So we got a bank object. Fine. We have in the bank object a class method called get account stream. Fine. We have already done that, right? We have put the method called get account stream. We prepared for streams. Okay, so I'm interested, given a bank object, let's see this. I'm interested in getting the average of all balances, and the code for that double average balance equals bank dot get account stream fine, get account stream dot, on the account stream use which method? Collect. In the collect method, what's the parameter? Collector. How do I get a collector to do averaging? Collectors class has a static method called averaging long. Parameter to this averaging long is an object of type too long function of account, right? Too long function of account. How do I convert from an account to the long value, which is going to be its balance? Account colon colon get balance. Given an account, give me the long value, the balance of the account, which is a long value. This is the too long function. Fine. Collectors dot averaging long returns to me a collector object. I don't have to write those 4 parts of the collector to get a collector. This is give me a collector. I have to just pass a function which can convert account into the long value. Other parameter is, so that's a closing bracket for this one, and semicolon, the result is available. You got the average. Average. Single statement. Getting the point? Averaging long. Because I'm going to, balances are of type long. I want average of balances. You want average of balances. Balances are of type long. Code is simple. Just say collectors. I have to pass to collect method a collector object. To create a collector object which can do averaging for me, method name is collectors.averaging. Oh, what's the type? Long, averaging long. Given an account, convert to long. Given an account, get its balance. So you average the balances for me. Fine, this is the code which works. Yeah, how easy it makes. Fine. Sum, if you wanted sum, then not sum, sorry. If you, yeah, even sum is possible. Yeah, even sum is possible. How? Summing long. Summing long. Collectors dot summing long. What's needed? Too long function. Fine, we even have something like long summary statistics. There's one class called in summary statistics, long summary statistics, and double summary statistics. Fine. Collectors dot summary statistics. Okay, we'll see what the exact method is. Fine, we'll come to that. But okay, is this clear? Averaging, counting. If it is counting, I'll just say collectors dot counting, no parameters needed at all. It returns the count. But anyway, if I was interested only in knowing the count, I could have done it by collectors. Stream dot count. Stream has a method called count also. Stream also has count method. Straight away on stream you have the count method, get the count. Right? Okay, another interesting one. Another method of another kind of collector. Clear? So we are now looking at static method of collectors, which return collector objects. Interesting collector objects. Okay, so some more methods. Okay, I'll put the method. Okay, it's a static method again. Fine. Type parameter will be you have anyway got t and we'll have what element type t. We have got k, t and k. Let's say k is what we call as a classifier. So this method would return a collector for t. Accumulator type doesn't matter, but what will be returned will be a map of t, comma, not t, sorry, map of, it's not t here, map of k, comma, list of t. Right. So this is the kind of collector we'll get. Name of the method is grouping by. Parameter to the grouping by would be a function which converts from t to k. This is known as a classifier. Grouping by. You give a classifier and can convert it into a map of this. I'll give the example to make it clear. Fine. You got the account objects, you have a stream of account. You want a mapping of, we know name is not unique. And there can be same name persons, so many persons with the same name. So there are accounts having the same name being used. Fine. And therefore, I want a map which says for this name, which are all the account objects. For a given name, give me a list of account objects. This can be a map. For a name, give a list of account objects. Mapping of K. K is my name. What's fine? Its return type is the map. Fine. When we said average, the return type was double. Here the return type is map. Maps from K to a list of T. Fine. String to a list of account. For this name, this is the list of account. What you need to pass is, for a given account, how do I get the name? That's a parameter. See how we can use this? So what will it return? It will return a map. Fine. So my return is a map. Map of string. String is nothing but your name, comma, list of account. Fine. This is my fine. Let's call the variable name as okay map of this. Let's have a variable name which gets this map as name wise accounts. Right? Name wise accounts equal to bank dot get account stream right, that gives us a stream dot for the account stream. Yes, what do we want? Which method? Collect. On a stream we have the method called collect, where we can pass parameter as a collector. The parameter to that is a collector. Our collector here is obtained by using the method static method on collectors dot grouping by. What's the parameter to grouping by? A function which can convert. What's a classifier? Getting the name. I wanted a mapped by name, grouping by name. For this name, what's a group? For this name, what's a group? Grouping by name. Name wise accounts, right? So, yeah. Account colon colon get name. Yeah. One step. Single statement. What you have got? A mapping created for you. It says this name, that's a list. This name, that's a list. Oops, sorry. Okay. Next. Again, grouping by further overloaded. You got a map of what? Name. For this name, these are the account objects. No, no, no. I'm not interested in name and their account objects. I don't want the list of account objects. For this name, the average balance is so and so. A map which says this name, don't give me account object list, but on that account object list, have a collector, we know how to do averaging. So on that list, do the averaging for me. Don't give me the list. I just want to see the average. Summarizing this list, right? So it's a map of string comma list of account? No. We can have a collector, one more parameter being passed, which is a collector to do the processing on this list and map it to that name. Okay. So yes, we can have another, this method. Let me put the method signature first. So we got this static method of t comma k. Okay. It returns a collector of t question mark map, which maps k to d. Let's call the, I'll need one more type parameter, t, k and d, sorry. T, k and d, 3 type parameters. Okay. It maps from k to d. Not a list now. Instead of list, we have put, in the earlier case, this was map of k comma list of t. That has changed to d, where we, the method name is still grouping by, but the parameter to the grouping by would be a function. Yes, first parameter is the function, which is from t to k. This is known as the classifier in any case, but we have more parameters now. So that's your classifier. A second parameter is a collector. Collector for t question mark d. This we call as the downstream collector. Yeah. It's a downstream collector. You want to create a collector? Fine. Give me a classifier and give me a downstream collector which can be used on the list. Recollect, classifier gives a list mapping of what is your classified type with the list of the stream type. It says no, you can give me a downstream collector so that I can map with those elements, not the list, but applying the downstream collector, whatever is the result generated. So we have a downstream collector which works on T, so that can work on the list of T.
So the downstream collector क्या है sir?
Let's use it. What are we interested in? Mapping account name. For this name, whatever is the list, no, I'm not giving you list. I'm mapping it with the average balances for that name. If this is the name, the average balance would be this. Or you want to see only the count. For this name, that's a count, not the list. I don't want to give you a list. I can give you count. Yeah. What's a downstream collector? For giving me the count. What's a downstream collector? Collectors.counting. First parameter is account : get name. Second parameter collector.counting. It's a map which is giving map of string to counting is long, string to long. A string to double, collectors.averaging long. Return type double. Okay, I'll just write the code, simple code, to use the second form of the method. Downstream collector, how it is used. Fine. So that's going to return a map of string, which is the name, comma, which one? You want averaging or collecting? Average. Name wise, I'm just giving a variable name wise averages equal to, yeah, what do we have? Bank dot get account stream, that's remaining the same. We have to work on that same stream. Yes, on the stream, call the method called collect. And to the collect, we need to pass a collector. Fine, so to this collect method, fine, we are passing a collector which is created like this. Collectors dot grouping by. For grouping by, now we are passing two parameters. First parameter is a function, which is my classifier, account to a string. Get name. Second parameter, grouping by has a classifier and grouping by has a downstream collector now. What's my downstream collector? Collectors dot averaging long. Account colon colon get balance. Yeah. Fine. Account colon colon get balance. This is my end of bracket for the averaging long. There's another end of bracket for collect. This one to match this one here. Yeah. Okay. That's a code. And this can be tried also. Grouping by. Okay, fine. There are many such methods, static methods to give us very convenient collector objects. Fine. Here we could even customize, you know what? It's returning a map object. What will be the type of map it will give me? What kind of map? Hash map or tree map? We don't know. Because that the function is going to create, right? You want to take control of that? We have one more method where we pass three parameters. First parameter, classifier. Fine, that's a function from T to K. That's my classifier. String here, account to string. Second parameter is a supplier of map. Supplier of map. Give second parameter as a supplier of map. So I can say, no, I would like to use a tree map. And third parameter is this, which is my downstream collector. So three parameter also can be used. In which case you are taking control of what object is used. How, when it says get method, it will use get on the supplier, right? So when it says get on the supplier to create object of map, which kind of map should it create? Oh, I want you to use tree map. And so that can be done. Fine. What you need to do in this same case, yes, comma, I passed this parameter, but before this, I could have passed one more parameter, which would say, fine, that other parameter here would be tree map colon colon new, and then this, and that's a tree map. What would be used would be tree map. It's a supplier of map. Fine? Okay. And so we'll continue tomorrow. And tomorrow, what we are going to do is we are going to look at, we might look at other methods, but we'll do more practical now tomorrow. Tomorrow, we can have a demo. Fine? Trying out these. And we'll be also looking at API and looking at the other methods of collectors. And so, with that, yes, this stream related things should be over. Okay.